With the basics of the system set up and the initial guess of flow rates made for each pipe and the flow direction in each pipe, all that done, we can now begin some of the calculations we need to. And let's start by calculating what Hardy-Cross calls the pipe coefficient. Pipe coefficient is just the calculation of everything that is given of each pipe. It's the lowercase r, and it's shown as 10.48 times L over C to the 1.85 times D to the 4.87. So we'll start with that calculation for pipe AJ, which goes to the reservoir down to the system. So I'm just going to type in here equals 10.48 times the length divided by C value to the 1.85 times the D value to the 4.87. Okay, so that gets us the R value, and then once you have the formula clicked in, you can just copy it and then holding the control button highlight the disconnected sets of cells and then right click one more time and then click on the insert formulas only. And that pastes the formula all the way into all the calculations in each of the loops. Alright, so the next calculation is the head loss, which is given as R times Q to the N. So, equal to R times Q. In this case, N is 1.85 because they're using Hazen-Williams formula. Again, we can take that, copy it. This time I just use Control-C to copy. Highlight the different cells, right click, and then paste the formulas. You notice there that a few of the formulas have this error that appears. And that's because we tried to raise the Q to the 1.85 and it's a negative number and it can't do that. So what we need to do is remove the negative, but because we want to sum up head losses, we want to preserve that sign, so we want to insert the negative back in after we've done the calculation. Alright, so we'll go back up to this top formula. So what we need to do is on the Q calculation, we're going to type in ABS and put the parentheses around the S3 cell. That's going to take the absolute value of the Q. But then we still want to have a way of saying, well, if it's negative, if Q is less than 0, then make this value negative. Otherwise, just leave it positive. So we put in an if statement in Excel. So we say if parentheses the Q value, which is S3, is less than 0, then, or comma, do a -1 times that quantity we set up. Okay, so if Q is less than 0, then calculate the absolute value. In other words, remove the negative, but then put it back in here. If it is greater than 0, then we put in the second comma and do the else statement. If it is greater than 0, then just calculate it like this. Right? So I'm going to highlight that section, copy it, paste it, close the parentheses. Now I have my formula. Now you have this formula there, okay, with an if statement. So once again, I'm going to copy that formula, highlight the cells where I want it, paste in the formulas, and now you have the values that you wanted. So here, like I said, when we calculate this, we pull out the negative, and then if the flow rate was negative, we put it back. If the flow rate was positive, we leave it out. So we use Excel to do some of the logic for us. Okay. Now the next value we need to calculate is this capital R, which is 1.85, the head loss, divided by the absolute value of Q. Okay. In reality, what this is you just need to make sure that these R values are positive, no matter what they are. So I don't know if we should do, I think it should be the absolute value of h divided by the absolute value of q, or just q, but these should all be positive values. So 1.85 times head loss divided by q. Alright, I didn't do the absolute value because the negative signs should cancel each other out. And that should be good. And paste all the formulas in there just like that. Now this R value is needed so that we can calculate the delta Q, the amount of correction needed for the next iteration. So delta Q is the correction value, and to calculate the correction value, that's why I need to calculate this R value, because the correction value, the amount of adjustment we need for the next iteration, is the negative sum of the head losses divided by the sum of the R values. So we calculate the sum of the head losses. So I'm going to go here to the cell equals sum, and I'm going to highlight that column, close my parentheses, and hit enter. Once I've calculated that, then I can just copy and paste this to the other places where I need to calculate the sum. So copy, I need to calculate it there, 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 and there. Once again, right click, insert formulas, done. So now we can calculate the delta Q, which is equal to the negative head loss divided by sum of the R. Alright? Enter. So that's our adjustment for the next iteration there. So what I want to do is I'm going to highlight that text specifically, copy by pressing Control Q, and then paste that into each one of these cells all the way down. Okay? Same thing here. Equals negative head loss divided by sum of the R's. Alright? And then I want to copy that formula all the way down. Don't drag it, because you want it to refer to that same, these cells right here. You want it to refer to those cells. So if you drag it, it'll shift it and calculate it all the way down. The delta Q for each loop is going to be the same number for all pipes. Alright? So I'm going to finish that off here by calculating the delta Q in the last loop. Alright, so now that we have our delta Q calculated, we need to calculate the adjusted flow rate for the next iteration. So I'm going to scroll over here. So the adjusted flow rate is our initial guess plus the delta Q. Alright? So that's true for all of these. We'll just go ahead and copy and paste that down all the way. Alright, the places where we do something different is where we have a shared pipe. For example, KE is a shared pipe. Alright, so I'm going to go here, KE, EK, whichever. You add on the delta Q from that loop, but then I have to go up here and subtract off the delta Q from the shared loop. So I go down here, KE, delta Q, subtract that off, done. KI is also a shared pipe, so I need to subtract off IK, delta Q from the shared loop. Alright, and IJ is not shared, so we'll just keep that the way it is. Right, so we'll go to the next ones as well. IK here, we need to subtract off the delta Q in the previous example. KG is shared here between those two loops, so I need to subtract off the KG factor, the KG correction from the shared loop. GH is not shared, HI is not shared, KE is shared, oops, not equals but minus, EF not shared, FG not shared, KG, GK is shared. So I'm going to subtract off the KG from the shared loop. Okay, so that's my adjusted flow rates for the next guess. Once you've calculated the adjusted flow rate, you've completed the first iteration. In part 3 of the video, we'll move on to how to run all the subsequent iterations in the analysis.